Okay, so it just occurred to me that this is not actually the second video. This is video number 4, because every time I tried to pause the video before, it was actually stopping it and starting a new video. So that was dumb. I'm not too smart. Okay. So anyways, video number 4. So we learned how to change a number from standard form into the polar or trigonometric r cis theta form. So let's talk about what we can do with these numbers. All right, so first of all, adding complex numbers, don't ever need trig form for that, okay? If you're gonna add two complex numbers, if you're gonna add 3 plus 4i plus 2 minus 6i, you're just gonna do 3 plus 2 and get 5, 4i minus 6i and get negative 2i. Excuse me. That's the way to add complex numbers. The r cis theta form doesn't help that at all. Neither will it for subtraction. However, multiplication and division is another story. So you learned in Algebra 2 how to multiply two complex numbers. It actually was one of the easiest sections that you did in Algebra 2. Sorry, I can't pause anymore because it'll start a whole new video. So every little burp you're going to hear. Anyways, it was actually one of the easiest things to do because all you did is FOIL here. And so here I've got two complex numbers. I'm going to multiply them out. So they're 2 times 4, it gives me 8. 2 times negative 2i gives me negative 4i. 5i times 4 gives me 20i. And then 5i times negative 2 gives me negative 10i squared. Okay, so negative 4i plus 20i is 16i. And you may remember that since I is the square root of negative 1, that means I squared would be this square root squared, which is just negative 1. So I squared is just negative 1. So this is negative 10 times negative 1, which is positive 10. And then I get 8 plus 10 is 18 plus 16i. So this 18 plus 16i is the product of these two complex numbers. Now, that's not that crazy difficult, I grant you, okay? That's not that bad. It's just foiling, replacing the I squared with negative 1, and there you go. Let me show you, though, what would happen if we multiply two numbers in polar form. All right, so if we did, I'm just going to make up some numbers here. Let's say we had 5 cis 82 degrees times 3 cis 120 degrees. Okay, now it just occurred to me that I need to show the proof for this, but the proof is in the book, and I could do it right now, but it's kind of long and complicated, so I suggest that you go look at that proof in the book. I don't want to pause, I can't pause the video to go get the proof and show it to you. And I don't want to take up all this space and whatever, so I'm not going to do the proof. You check out the proof. But I'm just going to show you how this works, okay? I'm betraying everything I believe as a math teacher, just telling you how to do this without proving it to you. But anyways, to multiply these numbers in cis form, here's what we do. We take the two r's, the 5 and the 3, and you multiply them. 5 times 3, that's 15. Then you got your cis. Then you take your two angles, 82, 120, and you add them. 82 plus 120 is 202 degrees, and you're done. That's it. It is that easy to multiply two numbers in complex form. You multiply the r's, you add the thetas, and there you go. So even though this wasn't that difficult, multiplying them in trig form is way easier. And I really am wishing that I could prove this. This is one of my favorite proofs. All right. Now, one word of advice here. Let's say we have 2 cis 205 degrees and 4 cis 300 degrees. Okay, no problem. We'll multiply the r's. So go 2 times 4, that's 8. We'll add the thetas. 205 plus 300 is 505 degrees. I don't want that angle to be bigger than 360. Okay, so you need to just subtract 360 from that angle, and 505 minus 360 is 145. That's the answer we want. We want that angle to be between 0 and 360. 505 is too big. So just subtract 360 from it, and you get a coterminal angle there. Okay, let's talk about dividing numbers in complex form. So I use those same two that I did up there. So let's say I wanted to do 2 plus 5i divided by 4 minus 2i. Now, the way that we had to divide these numbers is we had to multiply by the conjugate of the denominator. We called this the complex conjugate. So instead of 4 minus 2i, we multiply by 4 plus 2i. We're effectively creating a difference of squares here, right? And this is actually how you divide complex numbers. So on top, I'm just going to FOIL. 2 times 4 is 8. On the outer, I've got 4i. On the inner, I've got 20i. So that's going to be 24i. Last times last is 10i squared. But remember, 10i squared means 10 times negative 1. So that's really minus 10. On the bottom, I've got a difference of squares. So I'll do 4 times 4. That's 16. Negative 2i times positive 2i is negative 4i squared, which is actually negative 4 times negative 1, which is positive 4. Okay, so on top, 8 minus 10 is negative 2 plus 24i. On the bottom, 16 plus 4 is 20. We do not leave our answer this way. Complex numbers are written as a real number plus an imaginary number. That is not what we have here. We need to really do the distributive property with division. So we'll go negative 2 divided by 20, that's negative 1/10, plus 24i divided by 20. Let's see, that would be, so 4, right? Jeez, the cat distracted me over here. He's acting like an idiot. So that would be 6/5 I. All right, so there's your real number. There's your imaginary number, right? So that's how we write a complex number. That's the standard form of it. Okay, I'm going to make up 2 other numbers. Let's just maybe go with the 2 that I used up here, and let's divide them. Although I probably want to use some numbers that are multiples of each other. So let's say we have 20 cis 86 degrees divided by 5 cis 30 degrees. Okay, so we know how to multiply these numbers. Dividing them, you can probably guess how that works. When we multiplied them, we multiplied the r's. When we divide these numbers, we're going to divide the r's. So 20 divided by 5, that's 4. Then we have our cis. Then, when we multiplied, we added the angles. When we're dividing, guess what? We're going to subtract the angles. So 86 minus 30 gives me 56 degrees. And that's my answer. It's that easy. So much easier than dividing them when they're in standard form. If they're in polar form, really easy to divide them. Now, just a reminder, I'm gonna do a radian one here. So let's go 5 cis pi over 3 over 4 cis pi over 2. Okay. So when you are dividing these numbers, and you subtract the angles. Well, first of all, we do 5 divided by 4, so that's 5/4. And you subtract those angles. 1/3 minus 1/2 is 1/6. So that's negative pi over 6. That's not the angle that I want you to use. I want you to use an angle between 0 and 2 pi. So all we have to do is add 2 pi to that angle. Negative pi over 6 plus 2 pi is 11 pi over 6. And that's the answer that I want. Okay, so that is multiplying and dividing with complex numbers in trig form. In the next one, we're going to actually learn a very special theorem called De Moivre's theorem. I'll see you in that video.